Good morning. It's nice to see so many people here today on the third day of XMLPrague. I remember last year, this spot, Uche had this spot and made everybody sing happy birthday to XML first thing in the morning. And I expect all the gratitude in the world for not forcing you to do that this morning. I'd really like to thank all the sponsors for this event and XMLPrague itself. This is my second time I've been here, and it's been absolutely fantastic to finally meet all of the XML people that I've been working remotely for the last 15 years in your community. And it's great to be here in Prague, and I'd like to thank the Czech Republic and the Prague people for hosting us as well, because this is a pretty special place to be able to come. Today I'm talking about documents and data, and specifically I think what I'm talking about is a new capability in technology that we have. I wish it weren't specifically about MarkLogic, but it just so happens that MarkLogic has this new capability of being able to remain an XML document database, but also triple store. We can put RDF into the same database as all the XML and query it together or separately. And frankly, it's somewhat confusing to have all this stuff together in the same database. So this is a speculative paper, and some of it is speculative enough to be outright lies about the capabilities right now. But the idea is to just be provocative and get you thinking about what it might be to have structured RDF data and XML documents all together in the same database. I came to this topic quite a long time ago. Last year I talked about RDF and XML as well, but in a more of a systems architecture way. I managed an architecture where we had MarkLogic next to, alongside a triple store, and there were these various methods we used to combine and coordinate the data between the two systems. And it worked very, very well. But I always thought that, even before I worked at MarkLogic, I thought that this XML store would be a great way to store RDF as well, and it would be really intriguing to have the two things together. I also spent a lot of time with language technologies and geography and music as well. So since music is the one thing that doesn't overtly fit into this, I plan to torture you with accordions during the entire talk this morning. This is a picture of my baby that I had to leave at home, a Saltarell button box. So the first thing I want to talk about is just a very loose definition of what a document really is. I know that we could get very formal about it, but frankly, when you've got structured data embedded in documents or structured data sitting alongside documents, it's not all that clear. So what I think of when I think of a document is really something that has a container around it. And I think of a container really as being meant for, if not human consumption, then at least sequential beginning to end consumption. And we all know documents very well, and the fact that they can model very, very rich things is not lost on us. So they're extremely useful for mixed content scenarios where no other solution has really come along to handle the mixed content scenario. And if I think about a few different types of documents that exist, I would consider all of these representations of documents. Even the images themselves could be considered documents, because I could take that as a payload, stick it in the database, and query it, or look for it, search for it. So an envelope might contain a letter that's a document. Legal briefs, Bibles, even JavaDoc is a slightly more rich take on a document, but I'd still say that it's meant for reading rather than for any kind of more random access. And then I have a picture of a flight manual at the bottom, just because it's a very pretty document. And then when I contrast that with data, I'm really talking about this nice slide that everybody likes to bring up, the linked data cloud. This is what we enjoy looking at, slicing and dicing, analyzing, and really enjoying for its own sake. And it's the type of data for which the document boundary is not quite what we're interested in looking at. In fact, it's more interesting perhaps to consider the data that transcends the document boundary. So when I think about data, these are some words that occur to me. It might be structured, it's queryable, it's almost always typed, at least I would hope that data is typed. And then it's really what the focus of ETL processes is. If I'm going to bother to extract, transform, and load something, there's going to be a document payload on each side, but probably the very fact that I'm transforming it means that there's something more than just the document structure that I'm curious about. And here are some pictures of data. When I see something that's divided up into pieces, that's an indication that I might be thinking about not just something for reading or mixed content, but there's something beyond that. There's data within there. A graph is certainly a very common use for RDF, and so a graph is data. Any kind of table or entity relationship diagram, or sometimes you just have data and you can't argue with that. So inside of MarkLogic, this is what RDF looks like right now inside of MarkLogic, and you can go download it and start working with it with the graph store protocol or with XQuery. There's an XQuery API for manipulating RDF and parsing it. But when it comes right down to it, if I make an XML structure that looks like this, the sem triple, the wrapper doesn't matter, but a sem triple within this namespace is going to have a subject, a predicate, and an object. And anywhere I put this XML into the database, it's going to be indexed with the new special triple index. And I wish I knew where the camera was. I could say hello to John Snelson, who implemented all this stuff, and he must be either asleep or watching from his hotel room right now. So thank you, John, for doing this. You'll notice it's not a standard representation that anybody has seen before, but this is really more for the XML people who can look at this and say, oh yes, I understand what a triple is now. It's got 3 data points. The subject and predicate are always URIs, or IRIs rather, and then the object can be either an IRI or a literal typed value. And anywhere, I can mix this with any kind of content I wish. It doesn't have to be just sem triples elements. I can have a document with all kinds of content and then just inject these wherever I want. The triple index will see it, and I can run SPARQL queries or graph operations upon those triples. So right here, the facts that I have is that my accordion is a button box accordion. It has 2.5 rows of buttons. It has 2 keys. One's the key of C, one's the key of G. And I put a little bit of a label on the key of G so that we can read it in English in this case. So for me, when I think of contrasting a triple store to a document database, I think of taking all of this XML and throwing it into one particular corpus and then doing things with that. I can do full text search very, very easily. I can use XQuery on it. I've got tree structures I can traverse. And then one thing I really always liked about XQuery is it's an application server as well, which is never the case for a triple store. Nobody's built an application server into a triple store at this point. So on the other hand, the triple stores that are out there right now are really all about just storing this particular kind of data. And that, at least at my last organization, that was seen as a fairly big obstacle to adoption of triple stores because you always had to make it RDF first. And there was always a specific purpose for that type of database. But no longer. One thing I've noticed about data is that even though if I take my RDF and put it into a triple store, it's fairly explicitly put into one big bag. The RDF people might use named graphs to distinguish between sets of triples within the triple store, but I think that data really likes to be in documents anyway. Anytime I query a database, I'm going to get out an actual payload, and at that point, it is floating free from where it came from, and you can think of that as a document which contains data. So it's really documents that are involved in things like publication and interchange, and even query results are documents. So data is flowing through and in documents all the time, and I don't want to throw them away. Documents are first-class citizens in an XML database, and I don't want to throw that fact away just because I want structured data that transcends all of the XML documents in there. So what I'll do right now is characterize the different ways in which this document boundary and structured data can interact. And most of it's true even now in MarkLogic right now. And then I'll go on to say how data and documents might be related to each other within the data structure itself. And then I'll just throw out a couple of different scenarios that we've cooked up. One reason it's really nice to get this out in front of you is that we really don't know what the use cases are for this type of data yet. We know that it's great to have XML documents and it's great to have triples in the same database, but as far as mixing and matching, it really opens up some interesting capabilities that we'd like to explore. So here's my first convoluted slide. You've got to throw in a convoluted slide, at least. In brackets, I've got two different documents, each with one fact in them. One of the facts is that there's a patient who is diagnosed with high cholesterol. And that's represented vertically here, the brackets. And there's another document that says that hypercholesterol is a hereditary disease. And because these are two separate documents, we have security that we can apply already on these triples, which is something that's missing from most triple stores. But if I keep that document boundary and respect it, I can put different permissions on whatever triples I want. So if I run a SPARQL query against this database, and I'm the doctor, I can see information about the patient, but I can also have a publicly available data set for things that don't contain confidential records. So the security layer, you just get that for free. You don't have to do anything else to your XML database in order to overlay a security model on top of your triple store. Something else you can do is if you imagine a workflow where you have an accordion factory, you might take orders for accordions in one system. It occurs to me that probably most accordion factories are small enough so that they're not thinking about triple stores, but we'll assume that there's one gigantic one. All of you need at least one accordion, and so there's thousands on order, thousands under construction, and millions that have been sold. And each of these might be stored in an XML database in a directory structure. So I can actually feed in this case, a CTS directory query, and it'll filter all of the documents first before running the SPARQL query. So this is a way where I can provide context to a single type of query and just decide I'm only going to operate on certain parts of the database. And this could be a full text search to partition the database. It could be a directory query or any other kind of operation that I can do on XML. This is probably I have the complex slide, the silly slide, and the kind of slide that doesn't make a lot of sense, but bear with me. I like to think of documents as a very convenient state holder. So if I have a process where I'm going to have a valid state from 2002 to 2010, either insert a new document with some metadata on it to say the validity of a particular document or replace it. But I can have a whole series of documents which are distinguished by properties. And I can use those properties also to partition the database and decide that I'm going to, say, have a bitemporal scenario where I don't have to go around and monkey with my SPARQL queries in order to pay attention to temporal information. I can do that beforehand with a contextual XML-based query. So I'll go from here and think, well, okay, that's all pretty cool. But there's also the possibility of mixing and matching the data and the XML structure in various ways. So in this case, I've got a paragraph and a footnote and then an out-of-line information about that, that document. And then right after the document, I have a little bit of more structured data. Bandonio number 4288 is a certain size and is associated with Astor Piazzolla. So in this case, I've got one place where the structured data is marked up inline, another one where it's just a sidecar off to the side. And so the inline method is one first way that I might be able to mix the structured data and XML data. So RDFA, microdata, and schema.org are all ways to do this, where I have positional structured data scattered throughout the XML. And from the context, I know that I should be able to query with SPARQL the data which is implicit or which is explicitly marked up throughout the document. Now, this we don't do right now, but everybody thinks it would be pretty neat to take an RDFA marked up document, just insert it into the database and be able to query it right away. Right now we have to parse it and create the XML structures that you've seen before, but this type of thing is definitely on the roadmap. Here's just a picture I found of some inline markup that I thought was a nice way to understand inline markup. And then here's the diagram of where you might indicate the structured data that is throughout your markup. It gets extracted by the triple index. It gets indexed with the triple index, and then you can query it right away within the content. Another way I might be thinking is, I don't know what this is about, but the idea when I see this, it's just a mess of text, but it looks as though there's some other publication going on here, that I've got a document, but really I'm presenting a data set as well. And so I have the possibility of a new publication container where I have a whole bunch of pros describing what my data is, and then the data is right there in the document as well. And so this is a way that, that people who are publishing data-heavy research can wrap their data and their document up together, and it can be published into the world and managed in one place, and you don't need to worry about provenance problems when you're pulling the data out and using it for some other purpose, because it's always going to ride along with the original document. A third way, of course, is a more typical way of thinking of structured data and documents, and that is where you have two different views, two different documents, and one is referencing the other. So I might have a whole bunch of documents in my database, and then a whole bunch of triples that I'm managing in some other way, and they have references to the documents. So I just have the CRUD operations on the XML documents, and then another process which might have triples, and I can just reference them together within the same database. If I call fndoc on URI, I can get back the results of that from a SPARQL query. I can get back the document in line and the results of the SPARQL query this way. So when I think about what I might use the documents for then, it's really that we know well how to manage dependencies between XML documents. This is a well-known technique. And then the documents can also be the scope and a way to partition the database. One possible way I might use this is for rule-based inferencing. I've got a few triples over here about my button box again. It's got a certain wood finish, and then a couple different ways of labeling it. A button box is a class, and its label is button box. And then I've got another type of accordion, the melodian, which is a label of melodian. Well, it turns out these are the same thing. So I've got one document with the turtle on the left, another document which has ontological information which says that button boxes and melodians are really exactly the same thing. And then I've got a SPARQL construct query which says that if I find this triple pattern with the equivalent class, and I find an instance of class 1, I'm going to add another triple, this one down here, which says that any instance of class 1 is also an instance of class 2. Since I'm in a document database scenario, I can manage these all separately, and I don't have to have an external application to decide what the relationship is between all of the different triples. I can mark the first set as inferred. I can mark the ontology triples as an ontological document. I could store I suppose I could store the construct query somewhere too. And then I can have a document containing all the inferred triples. So I know if anything changes in the asserted triples, I can have document dependencies and blow away the inferred ones and run the process again. That's one type of data pipeline, but that's a generalizable thing I can do. Entity extraction is something people are very interested in. We saw a talk yesterday about entity extraction with ontological information. So if I've got this turtle, I think I probably see something different than you do when I look at this. But what I'm saying here is I've got several different classes of accordions, a single row Cajun accordion, a couple row button box, a 3-row Tex-Mex accordion. And then I want to use, each of these have some tags. So the tags, button box, diatonic accordion, melodian, Cajun box, Tex-Mex accordion, these are things I'm going to search for in text. So if I have a document that looks like this on the left, the Cajun accordion is still played in Louisiana, I can do a word search for the tags, and then I can generate annotations based on that search, and then store the results as another document. So this is a way where we can, within one database, do all of the entity extraction and taxonomy management that we'd like to do. And then the last scenario that I'd really like to bring up was something that hadn't occurred to me until I ran into a bunch of Java enthusiasts who, they really like their data binding. They really want a Java object, and they want to think in Java and really have the persistence layer be completely invisible to them. So it's already well understood how to map Java objects to XML, and the XML database is a great backend for this. But now, if we just think of it as another annotation we can put on here, we could add class information. We can add RDF right into the mapping as well. And then all of a sudden, your Java objects are not just isolated. They're within an RDF ecosystem where you can query for them and then return them as documents and just serialize them out as part of a simple SPARQL query. So here's a SPARQL query which is going to ask for every kind of, for every button box that I have in the database, and it's going to be returned as XML for the reverse process of marshalling it back into Java objects. So this is a way where you can write new data access layers using SPARQL or using RDF strategies, and yet also satisfy the Java people who really just want to think in plain old Java objects. And I think this is a compelling reason to provide new kinds of data access without forcing anyone to really go RDF all the way. So those are the three scenarios I've come up with, and then I'd really just like to open it up to see what kinds of questions and holes I've got in my reasoning.
Thank you, Charles. Mm-hmm. We have enough time for questions. We even have mics for questions.
Good morning, Liam Quinn, World Wide Web Consortium. This is one of the first talks on RDF that I've seen that talks about partitioning and context and security. And I'd be interested to hear your thoughts also about how this relates to implementing social systems with privacy.
Session systems with privacy?
With privacy, yeah.
Well, it's fairly analogous, isn't it? I suppose that the point is simply that the RDF people, linked data people in particular, are very focused on opening up everything, and security is a secondary concern. But in the XML database world, security has been a very, very upfront topic. And the fact that we can mix and match these now, it doesn't mean that it's the perfect solution for managing security concerns, but it does mean that we have the tools available already, and we don't have to go any bit further. I'm not sure whether that speaks exactly to the privacy question, but I'm probably not all that familiar with it either. Okay.
It's a bit of a related question, but I think in your scenario you say I have a security when in the database, but one intriguing promise of linked data is that the data can just sit anywhere. So I guess in your scenario you would not say I import the whole of DBpedia. You would rather just use the endpoint of DBpedia to query something, put the query result in the database, and then you have the small set. But that means that if you do it that way, you won't have security because the DBpedia data is maintained by somebody else. So I see you solve the security problem for the data which is inside you, but for these promises, I'm using data just somewhere. Do you have your vision of how to solve that there? Because
well, I think that you've uncovered a bias that I have, and that is that I think that this type of solution is really good for a business and enterprise situation where we don't have federated query. I haven't been thinking about federated query. So in order to run a SPARQL query against an RDF, it's all going to have to be in the same data store for now. So I am thinking of an ETL scenario where you decide what security you're applying to the data you bring in, and then run your queries based on that. But I think that it still holds, even in a federated situation, the idea still holds, because my data that I've got here is going to have one security context, and then data out on the web I'm querying is going to have a more open one, obviously. So it still will work. It's just that the external data is very, very open from the get-go.
I have one more question, which is related to...
It's John Snelson, MarkLogic. I just wanted to speak to the idea of security and privacy. What we found in MarkLogic is that there's a very powerful paradigm where you can kind of query for the set of triples that you want to look at, and then do a SPARQL query restricted to just those queries. And so security is just one instance of that, of a solution to that problem. Now, of course, if you look at something like Google+, where they have the circles and you share certain information with certain circles, that's obviously another instance of exactly the same problem. And at least for us, we'd solve it in the same way.
I think there's one over here.
This will probably be the last question.
Hi, it's just a very quick question. There was a little note you put early on in your slides just saying, I know it's not RDF XML, but here it is. Is there any reason why you didn't use RDF XML apart from the fact that the syntax is absolutely abysmal?
I think you just answered the question.
Right. Just checking.
The syntax is abysmal, but more importantly, it's difficult to index. We would have to parse that into something else in order to make it sense for the triple store anyway, whereas the XML structure that we have maps very directly to the index, and it's simple for people who. I also think it's nice to avoid RDF XML just because it's kind of a bad word. Absolutely, and we do parse it. We can import. He was asking if it was a standard that we intend to support, and yes, but it's a parsed data structure. Just like we can parse turtle and triples, whatever, but that's something we're going to parse and put into the internal format for now. The hope is that we'll be able to parse some of those and just insert it directly into the index without having to write out some other XML, but this is the intermediate strategy.
Thanks. Thank you.
Thank you.
Thank you, Charles.